2212 Lab 1, charged tape. The purpose of this experiment is to estimate the amount of excess charge on a charged piece of clear tape. Some important equations will be Coulomb's law, which calculates the electrical force, the calculation of an electric field, and a way to calculate the electrical force using the electrical field, and then the charge of an object at the observation location. Neutral objects in this experiment are interacting electrically with one another because they're composed of charged particles. Specifically, the two pieces of tape are pulled apart, causing charged ions or electrons to be transferred from one piece to the other. So, the computational models, of which there will be two, will be created in GlowScript. And some results for this experiment are that the U-tape will be found to be positively charged, with a charge of approximately 1.09 times 10 to the negative 8th coulombs, and approximately 6.77 times 10 to the 10th electrons are estimated to have been lost from the tape. For initial conditions, the system is two pieces of tape, the surroundings, everything else in the room. The mass of the piece of tape, which I looked up based on the length of the tape and the type of tape I used, is 0.0016 kilograms. This is the measured length and the measured distance between floating tapes. The procedure will be explained in the following slide. I first laid down a piece of base tape and then pulled off the two pieces of tape you see there rapidly. I tested how they were attracted or repelled to other objects, and then I brought up the lower tape to the raised higher tape to see the distance between them once floating, and measured that. My observations determined that the U-tape was attracted to my hand and then repelled another piece of charged tape, and then that a negatively charged plastic pen attracted the charged U-tape, meaning that the U-tape must be positively charged. To find the electric charge, I first need to find the electric force, and to do that, I need to find the gravitational force, since seeing as the momentum of the upper tape was 0 when it was floating, that meant that F net is 0, and the magnitude of the electrical force is equal to the negative magnitude of the gravitational force. So I found the gravitational force using the mass and the gravitational constant, and then I found the charge using the equation for electric force. And that charge was found to be 1.9 10 to the negative 8th coulombs. In order to find the number of electrons lost, I took the charge I just found and then divided it by 1.6 10 to the negative 19th coulombs as the charge of an electron. In order to find this ratio here, I first found the area of the tape, used the diameter of an atom to find the number of atoms on that tape, and then took the ratio. The computational model represented the equation just as I had in my written calculations as 2-point charges, and as such, it is very similar to the work I just did. I found all of my constants here, calculated gravitational force, the electrical force from that, and the Q from that, and then I calculated the number of atoms and the ratio. I printed everything out and then created two objects to represent the two pieces of tape with their charges, and then two arrows to represent the electrical force and the gravitational force respectively. As such, the charge was the same in both methods. For model 2, instead of representing it as 2 points, I represented it as 2 lines of points. And as such, after inputting the mass and then the charge I just found, and inputting the function I created in experiment 0, I had to create a line charge for the top tape and the bottom tape using the distance between the two tapes as my y-axis. Then this is the following result. This function gave us the magnitude of electrical force, and I had to work backwards from that magnitude to find the charges, just as I had earlier. And I found the magnitude of charge on one piece of tape was 0.000843 coulombs. Some potential sources of error were that I didn't take air resistance into account and didn't take into account how the U-tape B would interact with the hands holding U-tape A and other objects in the room when using U-tape A to make it float. I also definitely accidentally touched tape A or tape B at one point. So for the what if the electrons were positively charged and protons were negatively charged, like charges would still repel each other and opposite charges would still attract. However, instead of negative charges being the mobile charges and conductors, it would be the now positively charged electrons that would be moving. The tape and the pen would still be attracted to each other, but it would be the other way around in terms of which one's negative and which one's positive. So the point charge model value is much, much smaller than the line charge model value. They're different because the point charge model value treats them as 2-point charges, while the line charge model value treats them as a series of point charges, which is more likely to be closer to the real value because the actual tape is not a single point, but rather a line, as is represented in the line charge model. In conclusion, the amount of excess charge on a charged piece of clear tape was estimated to be 1.09 times 10 to the negative 8th coulombs. This experiment helped me to understand how neutral objects can become charged and how, once charged, they interact with their environment. Thank you!